for our next example, as for the simple linear regression application, is that the variable x is defined as the age of a certain model of automobile produced by the Mitsubishi Corporation, and the variable y is the current selling price in 200,000. Now, for the given 10 cars selected at random, the following data were collected. So we have the age of the cars, and then of course the corresponding selling price in 200,000 pesos. And then we have to find the equation of the regression line to predict the selling price of the car, and also we have to estimate the selling price of a 6-year-old car. So as you can see here from the given data, the oldest car is up to 5 years only. So we have to find the estimate selling price of a 6-year-old car. And again, for the solution, it is better to create a tabular solution. Now, wherein we have the column for the age of the car as the variable x, and the current selling price is the variable y. So we have this our data. The age is our x, and the selling price is our y's. And then similarly, in order to find the linear regression equation, we need the sum of the x and y and the sum of the x squared together with the sum of the product of the xy variables. Finding the slope intercept values or equations, so we need to look for the value of the a as our y-intercept and for the value of b as our slope. Now, finding the total of the x here, so we have a total of 26, and the selling price is a total of 35.5, and then later on we have to multiply it by 200,000. And then for the sum of x square, as we square each for the value of x here, so we have a total of 86. For the product of xy, as 1 times 4.5, 2 times 3.7, and so on, so we have a total of 84.8. And then using the linear regression equation, finding the y-intercept A and the slope B, so we have, for finding the y-intercept, we have the sum of y to be multiplied the sum of x squared minus the sum of x to be multiplied by the sum of xy divided by the number of observations n to be multiplied by the sum of x squared minus the sum of x raised to square. Now, from our tabular solution, we have a total of sum of y as 35.5, and the sum of x squared is 86, minus the sum of x is 26, and the sum of the product of xy as 84.8. Number of observations, the number of cars is 10, and the sum of x squared is 86, minus the sum of x is 26 raised to square. Then we can compute this using our calculator. We have a value of 4.61. Now, this is the corresponding fractional form of this, but you can also use the decimal form of the value. And finding the slope intercept B here, we have the number of observation n to be multiplied by the product of the xy, the sum of the product of xy, minus the product of sum of x and the sum of y divided by the number of observations n to be multiplied by the sum of x squared minus sum of x raised to square. Substituting the values that we have, for the number of cars, we have 10 cars, so we have 10 here, and then the sum of the product of xy is 84.8 minus the sum of x is 26 to be multiplied by the sum of y, which is 35.5. Divided by the number of observations as 10, the sum of x squared is 86 minus the sum of x is 26 raised to square. So using your calculator, you will get a negative value here, and this is equal to negative 0.41. So again, this is the corresponding fractional form of it, which is 75 over 184, but you can also use the decimal value or decimal form of it as negative 0.41. So as you can see here, we obtain a value of slope which is a negative. This is understood that the given or the forming line here is inclined to the left, and this is understood that the value is decreasing. So as the car gets older, so understood the price of it will decrease. So we have a negative slope. So the line is inclined to the left and it is understood it is decreasing. So we have the value or the linear regression equation here as obtained as y equal to 4.61 minus 0.41x. And then if you want to estimate the age of the car, so we can estimate now the selling price of the 6-year-old car here. So by substituting the age, which is our x, then we have the value of y here, which is the corresponding selling price of it, which is 2.15, and then to be multiplied by 200,000. So the selling price of a 6-year-old car now is 430,000.